Okay, so we're going to spend some time in this video multiplying fractions, right? And so we've already talked about adding, subtracting, and rounding, and we found out that for the most part, those things were the same as what we did with whole numbers, except we just had to take into account that now we have like all these fractions, parts of the whole on the right-hand side. What you're going to find out with multiplying is that it's pretty much the same. With the exception that we're going to have to do something at the end. So if you read what's written here, it says to multiply decimals, take away the decimal point for a second, kind of put it off to the side, multiply the numbers just like they were whole numbers, and then we're going to put the decimal point back in. And we'll talk about that in a second. So let's start with this first example, and we're going to multiply together 1.1 times 2.9. So again, I like the stacking method. So I'm going to say if that's kind of the same as doing 11 times 29, right? And so to recap, if it's been a while since you've multiplied fractions by hand, what we do is we start with the first number here, and we multiply it by both of these. So 9 times 1 is 9, and 9 times 1 is 9. Okay, and then we start use the second number as well, and we'll keep going if there's larger numbers like when we get over here. And I'm going to multiply this 2 by everything up here. But when I start writing down the numbers, it's going to go below the 2 instead of below the 9. So I'm going to say 2 times 1 is 2. 2 times 1 is 2. So if you notice, the 9, the numbers that I created, this 99 started below the 9, and with the 2, it started below the 2. Right? So that's just kind of your recap. And now that I have these kind of stacked list of numbers, I'm going to add them together. This is a 9. This has 9 plus 2, which is 11. Carry a 1. Okay, so 319. So what I did was I just multiplied together 11 times 29. Well, obviously I'm not multiplying together 11 and 29. I'm multiplying together 1.1 and 2.9. Okay, so what it says up here that you can do is you count how many decimal places there were and make sure that your answer has the same number of decimal places, right? So really what we're saying is this has 1 decimal place, this has 1 decimal place, that's 2 total decimal places. That means my answer should also have 2 total decimal places. So I'm going to make sure that I put the decimal point right there. 3.19 is the answer. So the multiplication is the same, but we just need to make sure that we place the decimal point correctly so that our answer reflects kind of the fact that there were decimals in the original one. And so here's why this makes sense. Okay, 1.1, we have this ability if we want to say like times 10, right? We can kind of move the decimal points over, but then we got to make sure that we move them back. So I kind of divide by 10, right? I had this number 319, and I kind of move the decimal point over and over it again for each of these places, right? So we're allowed to use the fact that this is all tens, right, to make our life a lot easier. So that's why this rule works, right? We're not really just making up something. It's using the fact that this is a base 10 system to move that decimal point around and make our lives easier, okay? Here's the other thing I want you to consider if you forget this rule or if you're not sure where to place the decimal point, is that your answer should kind of be somewhere in the vicinity of the factors that we use to make it. So 1.1 and 2.9 are pretty small numbers, right? 1.1 is like kind of close to 1. 2.9 is really close to 3, right? So it wouldn't make sense that our answer is, if I had 319, 319 is gigantic compared to a 1 and a 3. Right? Even if I placed it here, 31.9 is gigantic compared to a 1 and a 3. So it makes sense that our answer, 3.19, should be, that's reasonably close to the 1 and the 3, the 1 and the 2.9 that we started with, right? So let's go to, move down to, or move to the right, we'll do this one, okay? So I'm going to say 2.43 and then 6.5, okay? So this is kind of a little bit weird. It's like you want to place your decimal point over here because that's what we did with adding, but I'm actually going to place it right there. And I'm going to go in, see if I have a small enough eraser, and I'm going to erase this little decimal point here because I don't want to have to distract myself with them. I'm just going to look at the numbers themselves. All right, so here we go. Let me change color. So I'm going to say 5 times 3, 15. So that's 5 down, 1 up. 5 times 4 is 20 plus 1, 21. 1 down, 2 up. 5 times 2 is 10 plus 2 more. That's 12. Okay? And so I'm going to change color again just so we can keep track. 6 times 3 is 18. I'm going to place the 8 below the 6 because we've moved over. Okay? So 8 down, 1 up. 6. This is why I use colors. Colors are great in math. It keeps track of everything nicely. 6 times 4, 24, plus 1 more is 25. So again, 2 up. 6 times 2 is 12. 12 plus 2 is 14. Okay? Now I'm going to add these up. So I see 5, bring it down, 9, 2 and 5 is 7, 1 and 4, there's no carrying here, which is okay. That's going to happen sometimes. Okay, so now I'm going to look at these numbers and I'm going to say, all right, my original problem had 1, 2, 3 decimal places. So I'm going to make sure that my answer has 3 decimal places. I'm going to place the answer there. Okay? And again, I'm going to make sure that this makes sense. If I just forget about the decimals, 2 times 6 is 12. 15, right in that same ballpark. If I placed it at like here and had 157, that doesn't make any sense, right? So that's if you're unsure, if you're forgetting about something, just think about like where should the number be. Make sure your answer's in the same place. So 15.795 is the product. Last problem here. We're going to say 18 times 4.2. Again, I can just say 18 and 42. Let's do a little multiplication. 2 times 8 is 16. Carry a 1. 2 times 1 is 2. Plus 1 more is 3. Switch colors. 4 times 8 is 32. Putting the 2 below the 4. Carry a 3. 4 times 1 is 4. Plus 3 more is 7. When I add down the columns here, I get 756. There's only 1 decimal place here, so I'm going to place the decimal point right before the 6. Okay, so I would end up with 75.6 as the product of 18 and 4.2. Okay, so let's look at one that's slightly larger. Right, we got a lot going on here. Okay, so 14.964. Just curious what's next. Oh, tens are awesome. Okay, we'll talk about that in a second. So 14.964 and 18.331. Right, so this is one that's really all about organization. So again, I'm going to get rid of these decimal points so they don't distract me. I'm just doing a gigantic problem here. So let's say multiplication, and I'm going to say 1 is going to get multiplied by all these numbers, and my answers are going to start below the 1. Okay, so I'm just going to do 1 times 9, 1 times 4, 1 times 1. Okay, now I'm going to move on to the 3, and I'm going to say 3 times 4. And my answer is going to start right here. So 2, carry a 1. 3 times 6 is 18. 19, carry a 1. 27, 28, carry a 2. 12 and 2 is 14. Okay, carry a 1. 3 and 1. 3 and times 1 is 3 plus 1 more is 4. Okay, so that's my second digit, right? And I'm going to keep going. This is just going to be a problem that's more of a, doing the hard work as opposed to doing anything that's extremely challenging. And this is actually a good, kind of a good lesson that, in this case, this is not a hard problem. It's just a tedious problem. So it's something you're definitely capable of doing, even though it looks a lot more complex. Okay, 3 times 4, 12. Carry a 1. 3 times 6, 18. Plus 1. Let's not forget the one that we carried. Okay. Let's go back and fix that. Okay, so we had 3 times 6 is 18. This is why I like colors. That's 19. Okay, 3 times 9 is 27 plus 1, 28. Okay, so carry a 2. 3 times 4 is 12 plus 2 is 14. 3 times 1, okay, is 3 plus 1 is 4. Okay, all right, we're almost there. 8 times 4 is 32. I'm going to line that up below this. Carry a 3. 8 times 6 is 48, plus 3 is 51. Carry a 5. 8 times 9 is 72. 72 and 5 is 77. Okay. 8 times 4 is 32, plus 7 is 39. Okay. 8 times 1 is 8, plus 3 is 11. Okay. All right, we're getting there. This last one's pretty straightforward because I'm multiplying by 1, but I just want to make sure that this number, this last, when I do 1 times 4, that starts below the 1, so I'm going to make sure I follow that down. So I'm going to say 4, 6, 9, 4, 1, right? If I multiplied this 1 by everything, it's just going to be repeating that number, okay? So I have all this stuff going on now. We're going to add. Okay? We're going to end up bringing down a lot of numbers here, right? This 4 is going to come down. 6 and 2 is 8. 9 and 9 is 18, plus 2 is 20, so I'm going to bring down a 0, carry a 2. Okay? That's 6 and 8 is 14. 14 and 9 is 23. 23 and 2 is 25. Okay? Here I have 3, 7, 15, 16, 20. Okay? 6, 10, 17, 23. Okay, 6, 15, 24, and that's 7 and 2. Okay, so I end up with this gigantic number again, but I have a bunch of decimal points here. 1, 2, 3, 4, 5, 6. So I'm going to go down here and say 1, 2, 3, 4, 5, 6. This is what I need. Okay, so again, this is like a very tedious problem, but I want whole reason I even did this problem was to show you that we didn't change anything that we did. Okay, we lined up our place values properly, we multiplied as if they were whole numbers, we counted how many decimals there were, and we placed it appropriately. This is not a problem that anybody that I know is not capable of doing. It's just a tedious problem. It's something you need to be careful with. You need to be organized with. You can see that, for example, I was using colors to try to keep track of everything. And those are the kinds of skills that you want to work on so that you can start telling the difference between things that are difficult and things like this that are just tedious and a lot of work. Okay, so I think that everyone's plenty capable of doing this type of problem. As complicated as it looks, hey, you can do this. Okay, so let's talk about a nice little trick, and then we'll finish up our talk about multiplication. Okay. Tens are our favorite thing, and the whole reason that we love tens is because, remember, the idea is that decimals are based on tens, right? It's 1/10th and 100th and 1,000th and 1/10,000th that are all multiples of 10. So when we multiply by a 10 or a multiple of 10, what ends up happening is that you just end up moving the decimal point to the right. Okay, so let's take a look at this problem. So again, we just saw with this one, that was a lot of work with all these decimal places with big numbers. If I look at this one, same idea. If I was doing 100 times this and having to write all that out, it would be a lot of work. When I multiply by this, I'm going to say what is the number of zeros in my problem? In this case, there are 2 of them. And that's just going to allow me to move the decimal point in our original number 2 places to the right. It makes sense that I'm moving to the right because multiplying by 100 should make your number get larger. If I moved it to the left, I'd end up with 2.5, right? That's much smaller. So if I move this 2 places to the right, I end up putting it right here, and I end up with 25439.543, right? So that's why tens are awesome, because we don't actually have to go through the process. We can use this nice fact that decimals are based around tens and multiples of tens. Right, and that makes it move the decimal point. So again, if I had multiplying by 1,000, I see 3 zeros. Here's what I'm going to do here. I'm going to say move it once, move it twice, move it 3 times, and I'm going to put a 0 in that last space. Okay, so if you ever are too close to the end and you can't move it 3 times, you put a zeros to fill in all those blanks. So 11, 345, 220. Okay, 11,345,220. Is this number multiplied by 1,000? Okay, so use this nice little trick whenever you're working with multiples of tens. Instead of having to go through all of the long multiplication work, use the fact that we're working with multiples of 10.